Why don't you just like put it on the box?
Are you right? Get that. Go.
Okay, you have to know for matter and energy, you have to know that if it's a substance, it will be an element or a compound. If it's a compound, it can only be separated by chemical means. If it's a mixture, it can be separated by fractional distillation. If it's two liquids, by dye. If it's a dye, it can be separated by chromatography. And if it's a heterogeneous mixture, it can be separated by filtration. If you're asked what a solid is, it has a regular geometric pattern. So you see regular geometric pattern, you look for a solid. You see it takes the shape of a container, you look for a gas. If you're talking about a physical change, as a substance goes from a solid to liquid to gas, it's absorbing energy. So in that direction it's endothermic, in the other direction it's exothermic. You have to know how to answer questions with the phase diagram. As the diagram goes like this. Your kinetic energy is going up, the potential goes up. Kinetic goes up, potential goes up, kinetic goes up. This is the freezing point or melting point. This is the boiling point. If you're at 0 degrees, you have to take the grams and times it by I lost the number. You have to times it by 334. 334. If it's at 100 degrees, you have to take the grams and times it by 2260. If you have two temperature readings, you have to take the grams. You have to you have to take the change in temperature, and you have to times it by 4.18. You have to know for the gas laws that gas molecules are in constant random straight line motion. They hit the walls and build up pressure. They hit each other and transfer energy. They have no volume. They have no forces of attraction. You have to know that for a real gas, it deviates because it does have volume and it does have forces of attraction. But hydrogen and helium will behave like an ideal gas. And if you wanted a substance to behave like an ideal gas, you have to decrease the pressure and increase the temperature. And if it does behave ideally, you use the formula V1P1 over T1 equals V2P2 over T2 if there are two temperatures or two volumes or two pressures. If not, you have to use Pivner. That's what you have to know for matter and energy. For atomic structure, you must know the history of the atom. You have to know that John Dalton thought it was a hard sphere, but then J.D. Thomson discovered electrons. And then from the gold foil experiment, Rutherford found out that there was a nucleus where the protons were and a lot of empty space. Bohr thought those electrons traveled in orbits, but he was incorrect, and today they know they travel in orbitals. You have to know for a symbol that the top number is your mass and the bottom number is your charge. And when asked if you were given the symbol 614-6, how many protons does it have? It has 6 protons. As long as they call it an atom, it has 6 electrons. But if there's a charge on it, you got to make sure that you do opposite of the charge. If it says +2, you take away 2. If it says -2, you add 2. And to get your neutrons, you have to subtract the 2. If you do subtract the 2 and you find out that two substances have different number of neutrons, you call it an isotope. In order to calculate the average mass, you have to know the different masses of each.